All right, welcome back, kids. Today it's intro to sequences. Just gonna give this our best shot here. You guys learned about sequences last year a little bit. I could just give you a few easy ones. The sequence starts with 3 and 5, and then it's pretty easy to predict that we're adding 2 each time. Some of the questions today will look like this. Pretty easy, and I don't want to downplay how easy it is, but in the worksheet number 5, Introduction to Sequences, some of them are literally that easy. So let me just scoop myself down here. Here's another one. This time we added 2 to get 3, and then we added 3, and then we added 4, and the question will be, what do we then add? So you'd have to think to yourself, to get from here to here we added 2, from here to here we added 3, from here to here we added 4, so we most likely are adding 5 this time. You get 15, 21 because you add 6, etc., etc., etc. Here's another fairly common one. This sequence starts with 5. I know you're thinking that you're adding 5 each time, that's what it looks like, but in fact, we're doubling. So you just got to kind of use your brain and think to yourself, all right, what's a way we got from here to here? I mean, there could be a few ways. This one, possibly we added 5, but then that fails. That's not adding 5. You could say here that we multiplied by 2, and there we also multiplied by 2. So then hence, it seems like this one would be 80, and the next one 160, etc., etc., etc. Many of the sequences are going to be what's considered linear, another name for linear, and I just mean that you're constantly adding or subtracting the same amount. The fancy word they use is arithmetic. We talked about this last year a little bit. So for instance, from 2 to 5, we added 3. And if they tell you that it's an arithmetic sequence, that means you're always going to be adding 3, etc., etc., etc. We're going to talk about how to write these, or how they might look. Many, like that last example, they would say something like, the first term of your sequence, that's what that 1 means, is 2. And the second term of your sequence is 5. And the third term of your sequence is 8. And the fourth term is 11. They may ask a question like, what is the 10th term? You just kind of got to do the math and think to yourself, well, we're going to constantly add 3 here several times. So it takes a little bit of thinking. Another way we could write this information, n is what's called the index, kind of indicates which term of the sequence you're on. And it almost always starts like this with your counting numbers. This is the name of the sequence, and the last one, it was a sub n, because there's a little n down here, so it's pronounced a sub n. I'm going to do the same thing here. If I just kind of randomly pick one, we'll start at 100. Again, if this is arithmetic, you know that you're always adding a -3. That's how we write it. And you're going to add a -3 each time. So this would be 94, 91, 88. Some of the questions will say, list out the next 5 terms. Some will say, ... find the 10th term. There's another type of sequence. This is what's called the type where you're multiplying. It's usually with a G for geometric. Arithmetic, you add. Geometric, multiplying. So let's say it's 5 and you're doubling to 10, 20, 40, 40, 80, etc., etc., etc. They still might say, now find the 10th term. Some of you will have to determine all the intermediate values. There is an algebraic shortcut. That's what we're going to get to. You could also graph these sequences and put them more like this. If they give you an algebraic formula, they might say that the sequence is 3 plus 2n. To figure out the first term, I'll put a 1 in there for n and a 1 in here for this n and do a little math. That's 3 plus 2 times 1 is 5. The first term is 5. To figure out the second term, you're now going to put a 2 in for n. This is 4 plus 3 is 7. To figure out the third term, you jam a 3 in there and you get 9. And you'll notice that you have an initial value. You're starting with 5 and you're constantly adding by 2. That's an example of an arithmetic. You could graph these as such. You put your counting numbers down here, 1, 2, 3, 4, 5. A lot of times you try to pick intervals that kind of make sense to what we're doing here. I'll just go by 5s. 5, 10, 15, etc., etc. Your first term in this instance is 5. The second value is 7. The third one is 9. The fourth one would be 11. This is why we say it's sort of looks like a line. You really would not sketch a line through here, but to help you visualize, I mean, it certainly comes from a linear equation. You graph. There's a variety of other. There's arithmetic, which you add, geometric, which you multiply, and then something called neither, and neither is just a big open window to what those look like. For instance, I could just call this this sequence. This is the algebraic expression. When you put a 1 in for n, you square it and you get 1. When you put a 2 in, you square it and you get 4. When you put a 3 in, you square that and you get 9. Now you're certainly not adding 3 each time, and you're certainly not multiplying by 4 each time. This is one of the big ones we call neither. You could have this crazy expression as well. I'll call this the C sequence. You take negative 1 to the power of n and multiplied by n. Let's say this is crazy, but we're going to give it a shot. When you put a 1 in here, you also put a 1 here, and you put a 1 there. So to figure out your first term, we're putting a 1 in those 3 spots. When I evaluate my first term, negative 1 to the power of 1 is negative 1 times 1 is negative 1. Now when I put a 2 into those values for n, negative 1 squared is positive, and we're multiplying by 2. So your second term is 2. When you put a 3 in here, I suppose I could just do this. When you jam a 3 in there, negative 1 to the power of 3, that goes back to negative, and multiplied by a negative 1 times 3 is negative 3. This is what's called an alternating sequence. I think you can see that the fourth one will be positive 4, the fifth one will be negative 5, etc., etc., etc. To graph it, it's going to get a little crazy. Your first term of your sequence is negative 1. The next one is positive 2. The next one is negative 3 and positive 4 and negative 5. Again, not linear. It's called alternating. The alternating just means that your signs, or pardon me, yeah, the value of your signs toggle back and forth between positive, negative, and they kind of flop above and below the x-axis. I'm going to just glance at the